what I had before. So let's take a look. The domain is negative infinity all the way to negative 2, not including because of the dot right here, scanning from left to right. And then union from 2, but including right here, 2 right here. So it's going to be 2 to positive 2. Negative 2 to positive 2, including because of the dots here, x value wise. And then union, a cut. And then you're going to go from the positive 2 to infinity, the way it's pointing it to. It's not just pointing down, it's pointing also to way to the right. Now the range, okay, have a look. It's easier than that. The range is that when they're cuts or anything, you don't account for, you don't care. So we were talking about from way down on the bottom, but don't forget it stops at 4. It's not all real numbers, right? Look, it stops at 4, the y value. So it's going to be, the range is going to be from negative infinity all the way to 4. And don't account for the breakage in anywhere. So it's not the same as the domain. The domain will be, you have to account for all the cuts, even though they overlap, they continue on and all that, but you have to write them. But for the y, just write all of what you can see. But if there is a cut, you have to identify it. But there is no cut. You see why? It covers everything. This is included right there, the y value, and this y value is included right there. So they're all connected. The y's are all. You get all the y from negative infinity all the way to 4. There is no cut anywhere, or there's no gap anywhere. There you go. Is that okay? So that should be the answer for the range, domain, and the range. All right. So, okay, I think you wanted to look at this, right? Shall we look at it, or do you want to continue more over here? We didn't do this yet.
Yeah.
What do you think?
I think we can go to 25.
Okay. All right. 25. Factor completely, right? You look at the number kind, 3 and 9, and then the variable kind, the a and the b. So you notice that the 3 can be factored out because the LCD, least common multiple, but yeah, 3 can be pulled out, the number kind. And then what about a? No, because there's no a in each one. So therefore, you leave the a alone. But the b, you have to pull out. Now, which b do you pull out? The smallest b. Just like, between 9 and 3, you have to pull out 3 because you'll see why here. If you write out what you need here, you need a 3 to get a 9, you see? Right there. But now, let's see. A, so this is going to be your GCF, they call it, right? The greatest common factor. So it'll be a minus 3b. Let's see if you agree, because if you distribute it, you'll get back the original. 3b, yep, 3b, 3 times b, yeah, a, and minus 3, 9, 3 times 3 is 9, and then b squared, yep, that's it. So that's done. This here, 4 terms, make sure that, hey, if you notice that it's 4 terms, you have to do it pretty much this way, by grouping, they call it, right? Grouping. So you do 2 at a time. The first 2 separate from the last 2. Try to not look at the last 2, or imagine you don't look at them. Go with the first 2. So what's the greatest common factor for the first 2? It should be x squared. And no number, because there's no number that can go into both of them. So just x squared. And then you come up with, hey, x squared times what will give you 4x to the third? It'll be 4x. And x squared times what will give you a 7x squared, so it's just plus 7, so forth. And then when you're done with that, you pretend you never seen this, and you start like over here, brand new, like over here, brand new, like this, the next 2. So the next 2, I'll even cover this over here. The common factor between 40 and 70, a 10. But if this is negative, you have to pull out a negative 10. Let me align a little bit. So a negative 10 will be the greatest common factor between these 2 here. If this is negative, make sure it's negative here. If it's positive, it's positive. So negative 10 times what will give you a negative 40x, so it will be 4x. Negative 10 times what will give you a negative 7. 70. So it's going to be plus 7. Let's see, you okay with that? Double check here. Yeah. Now, if you do this right, this 2 must match. There you go. That's why I cover that. If you do factor it right, then they match. But once they match, you pull, you do the grouping. You could put it in the front, you could put it in the back. So I'll put it in the front, it will look like this. The two that's the same, you pull out once. It's basically distributed property backwards, like you factor it out, but don't worry, you can memorize it. Pull out, put it in the front or in the back once. But once you're done, you put this together for the second factor, just one time, one by one, like there. You see that?
Yeah.
That's it. Now, this actually can be continued further. Oh man. But I think you're done here, but you can stop, but I'll go ahead and continue anyway. Let me show it to you. I don't think you're supposed to be doing this though. Because I don't know whether you actually do the factor in root. I never seen it, you guys do it, but it works if you try to do it. If you FOIL it, the outer inner cancel, the last, a root 10 times a root 10, it's a 10, or root 100, but then root 100 is 10, but it's a minus. So this is actually continuable. Your teacher may actually try to mess with you here. So, but I think your teacher will accept the answer being just that. So it's up to you.
Okay.
Yeah, if you ever have an x squared minus a number, it doesn't have to be like a 25. If it were 25, the a 5 and a minus 5 here, right? A perfect, yeah, the difference of squares, they call it. But even if it's with a 10, it will still, you can still do it if you wanted to. Yeah, just write that. I think your teacher will accept this, I promise. But just be aware, you can only do that if it's a minus. Yeah, it doesn't matter what the 10 is, just root it. A 9, you can root the 9. Yeah. No, not a 9. It'll be 3 plus 3 here and a minus 3 here. Sorry. Only non-perfect square numbers. Yeah. Okay. Same thing. First 2, last 2. First 2, common factor is x squared. Yeah, ignore this last 2. X squared times 12 will give you 9x to the third, will be 9x. X squared times 12 will give you a minus x squared, so a 1. Like that. And then, again, don't look at the first 2 completely. Again, if this is negative, the next 2, the first one of the 2 will be negative. Pull out a negative. It will be a negative something. So what's a common factor between 18 and 2? It would be a 2. So a negative 2 will be the common factor. And then negative 2 times what will give you negative 18x back. It will be a 9x. A negative 2 times what will give you plus 2 back. It will be a minus 1. Right? Negative 2 times a negative 1, positive 2. Yeah, again, here it is. If you do it right, this must match. If you get it, you can put it in the front or in the back. So this time I'll put it in the back. But once you put it in the back, this will now be gathered together like this. Just like that last one. But then I'll put this together one time in the back. It's really factoring, by the way, of an expression, a binomial expression out of this whole thing. But a lot of people have a hard time eyeing it or seeing it. But you could just memorize it, the pattern. Yeah, pull it out. The one that repeats, put it out once, either in the front or in the back. But yeah, so this time I put it in the back, so you see that you can do that, and that's in the front. And here, you can stop, or you can do this. So you can stop here if you want, but you can also factor this one. Since this is not a perfect square. Had it been a 25, it would be a plus 5, minus 5, but you can still do a root. I'll do a plus first, root 2, minus root 2, root 2, and then 9x minus 1. If you want, you can stop here. I think your teacher will accept that. But this is actually completely factored. I know it says completely factored, therefore there's a chance that your teacher wanted it. So careful. So I don't know, dude. Yeah, because normally they don't care for you to write the root form. Yeah, so that again. Anyway, this one, you got that one, okay, Russell? Okay.
Yeah.
Okay, this one, a trinomial. I recommend you do the guess and check or try and error method. To get the first, to basically come up with the combination of the first and combination of the last. The last, I will do a 5 and 5. The first has to be either 9a here or 1 and 1a there. But I recommend you do it the two ones that close to each other, which is 3a and 3a, or the same, I guess, like that. And then test this out. If it doesn't work, then change the combination, including the 5 and 5. It could be 25 and 1, but I doubt it. Okay, continue with this. So if you check the outer, inner. If the outer and inner can get you a 30, don't worry about the negative. By adding, subtracting, it will. It will give you a 15, 15. You see it? 15, 15. It will get you 30a. So yeah, 3a and 5a is 15a. So yeah, you'll get it. But that means to get a negative 30, they both must be minus. I hope you're okay with that. See it?
Mm.
And this is done. So like if you check it, it will give you everything. You foil it, right? The outer, it's going to be negative 15a, and the inner, negative 15a. That's why it's negative 30a. And the last, negative 5, negative, positive 25. And the first, 3a, 3a, 9a squared. Now you can stop right there, or you can write this form if you want, a squared. You know, the thing repeats, you can write it as a squared. But it doesn't matter. This one, your teacher accept either one for sure. A squared, because they repeat. So this. Okay, this one, man, I hope you're okay, because you have to go back and recall your formula. I'll put it up here. The formula is a plus, it could be a minus too, don't forget. Oh, so it's cubed. A cubed plus b cubed. It's going to be equals to a factor of a plus b. Same here, like soap thing. Let me see. And then a squared minus ab, opposite here, and then always plus back here. Remember that one? And then,
Yeah.
yeah, and then if you have a minus here, it will be a minus here, then it'll be a plus here, and then it'll be a minus here. If this were a minus. But the last, I'm sorry, the last, it's always plus. Sorry, always plus. I'll even write it if you want. A squared, a cubed minus b cubed, a minus b, a squared plus ab plus b squared. Okay, now you're going to use that. But you can't just, do it right off the bat unless you can see it. I recommend you rewrite this to make an A out of it. Now, the A and the B could be parenthesized individually, parenthesized like that. I'm talking about the front one here, okay? The one before you factored. So that means I can get my A by rewriting it as 2x to the third power. That's your A. Your B is just 1. You can parenthesize it to emphasize it, meaning that this is like parenthesis A to the third, parenthesis B to the third. You see that? That's why it works. So that means your A is literally 2x all the way through. So if you continue, I'm about to write this part right here, okay? This is rewritten to be this right here. So here we go. I'm about to start writing this right here. So this is this right here. So now I'm about to write this right here. I know I'm like indented over a little bit. I should actually put it right directly above. But okay, I think you follow. Now, here we go. I'm going to do a plus b parenthesized. So it'll be 2x plus 1. That's this one right here. And then the trinomial, it'll be 2x to the whole thing squared. But I recommend you actually go and simplify it right away. It'll be 4x squared. I hope you can see that.
Okay.
A squared, this is a, therefore it's going to be 2x times 2x. But then minus a times b. So it's 2x times 1. It's just going to be 2x. And then the last, 1 squared. B squared is 1 squared. That's it. You're done. And I think you might remember that I was telling you that the trinomial from like the sum and difference of cubes is never going to be factorable. So you don't want to ever attempt to factor that. You're done. So try not to continue on. Don't do that. Yeah, you waste your time. So this is final. Yeah, so if you're using the formula for the sum or difference of cubes, this right here, the trinomial back here can never be factored further. So don't bother. But you can solve though. You can set it equal to 0 and use quadratic formula. You get I, in it, but this is not it. You're not solving. It's just factoring. So that can be done. But I remember doing this with you too, but not these ones that you're doing. Okay, anyway, factor this one, a trinomial. I recommend you go ahead and do a try and error. 2c and c will give you the first. Just do the first and the last. The last, I'll do the number close to each other, like 5 and 3, or 3 and 5. You can do 5 and 3 here, but I'll do it this way first. Now you might let me do it wrong first. I'll do it 5 and then I'll do 3. So if I test it, I get a I get a 6c and I get a 5c, the outer inner. If I combine, I'm not getting 13c. I'm getting 11c at most, and one. If I subtract, I'll get 1c or negative c. So that means I have to flip. I'm gonna have to change this to be a 5 and this to be a 3 to give you 15. And then I'll check it again. I get a 10c and I get a 3c. So yeah, I can get a 13 now. You see that? Hope you okay? That means they're all, and they're pluses. If they're all pluses, this is plus. These two are plus. That's it, done. And you can foil it to prove it. And yeah, it's all good. And that's done. For number 30. All right, let's move on. You okay? You got that?
Yeah.
Let's move on here. Is that continue? That's the continuation of this, right? Yeah. All right. All right. This one, same way though, but you must look carefully here. You can see that there is a GCF that you can pull out. So this one is, you can look at it and you can tell this is GCF. And this one, there's a GCF before you continue, and this one. So they made it. So if you look back at the one that we were doing, there's no GCF here. There's no number or a variable that you can pull out from the three terms. Same thing here. There's no number or anything that you can pull out before you continue. This one, you can see that you do have it. So what is it? Well, the number kind, nothing. You cannot pull anything kind. The number, you can pull out the x squared, because x squared can be divided into all of this. So x squared is pull out the smallest of the powers, which is x squared. And then you think x squared times what will give you all of this back? Here, 3x second power plus 2x minus 40. I hope you're okay. There. And then continue on carrying the x squared as part of the factors. So continue factoring it the way we were doing it. So do the first and the last. So the combination will be 3x and x only for sure. The last, they're plenty, but I'll do the number that's close to each other again, which is going to be 8 and 5. Yeah, 8 and 5. You can do, 4 and 10, but don't. Try to do that later, or even 40 and 1. But yeah, when they do this, like 80% of the time, the number close to each other will work, but not always. So 8 and 5. I would do 8 out here and 5 here. Can I ever get a 2x out of it by subtracting or adding? No, because it's too far. 8 times 3 is 24 and 5. No, it's too far. So I'll switch the 8 and I put an 8 here and do a 5 here. So I get a what is that? 15, and I get an 8. I can't get a 2 still. You okay? So I can't get a 2 still. That means you'll have to now resort to the 10 and the 4. But I'll do a 10 here and then I'll do a 4 here. But again, if I put a 10 here, it'll be too far apart. 10, I'll get a 30. You see that? And a 4. No, I can never get a 2. That means I'll do a 10 here and I'll do a 4 here. Now I can see I can get a 12. I mean, I can get a 2 out of it, because the outer will give you 12x, inner will give you 10x. If I subtract, I'll get a 2. See? So that works. That means, okay, I'll keep them where they are. Now I have to get the sign correctly. If I do this sign here, negative, I'll get a minus 12x. If I do a plus here, I'll get a 10. So I won't get a plus 2, I'll get a minus 2x. So I have to switch the sign. I do a plus here and a minus here, because now I can get a positive 12x and a minus 10x. If I combine them, I get a plus 2. So that works. Done. So you can see all like the brainstorming that I do, if you wonder. Yeah. So this is it. And you can check for the last being negative 40 right there. And the first will always work. So this is done. Yeah, no further. Done. Okay, same thing with this one. The GCF is 5. I think you can see it. The number kind and with 5 and 5, you can, they're both divisible by 5. So pull out a 5 first, be x to the third, and then we'll go back to the difference of cubes again. Okay, now, but this one, 5 can go into 135. Let's see, 2, 5. What is that? I'll write it over here. I just use a calculator. 2, 10, 35. Okay, so it's 27 times? Yes. Oh, yeah, it's the cubes. Dang it. I was hoping to get a perfect square. So it's 27 times. Okay, then now you have to use this again. This time I'm writing it right above it. So you have to use this difference of cube formula. Again, same here. Opposite here, but it's a squared plus opposite right here, the sign. AB, then plus, always plus b squared. So you're going to use this one. But then again, you cannot use it until you rewrite this into the b to the third power. The a is x, so we're done with that. Minus is minus right here. Minus, minus. But 27 can be rewritten as 3 to the third power. So your b is 3. Oops, I'm sorry, this is actually cubed. Sorry. Okay. Anyway. So x to the third, same. But this is going to be 3 to the third. Okay, now continue. I'm about to continue with this, but with the 5 in the front. So I'll write 5. And then okay, I'll write it sideways here so you can see it similar to this here. So 5 stay 5, but then I'm going to write this part from here now. It's going to be just parenthesis ax minus 3. See that? Then continue here. And then a squared, which is going to be x squared, plus ab, this times that. No minus or anything, okay? With already, you already established that x is a, 3 is b, not negative 3. It's just the minus in between. So it'll be 3x plus b, which is 3, 9. Okay, done. So this is done for this problem here. Again, we don't factor further because that's not factorable from the difference of cubes and the sum of cubes. So 33, continue here. The number coming, like the 5, 14, and 3, nothing. There's no common factor there. So a is the only common factor. The greatest common factor would be just a, and then copy, and then, yeah, just a, and then a times what will give you that back. So a times a to the second power, a squared, plus 14a minus 3. Okay, I think you're okay. And then I'll continue here. And then factor the trinomial here by guess and check, try and error. Again, 5a and a will give you the first and the last. It's only 3 and 1. Don't worry about the sign. 3 and 1. If I do, yeah, I'll do 3 here and 1 here because the outer will give me 15, the inner will give me 1. If I subtract, I'll get 14. You see that? So the outer 15a, inner is 1a. If I subtract, I'll get my 14. But then what about the sign? Well, I want the positive 14. It has to be the bigger one. So it has to be here. Because if I multiply it like this, I'll get my plus 15. And then I can do minus here, I'll get a minus a. You see that? So a plus 15a and a minus a. So I get my 14. So that's done. So that's correct. Minus here. And the last, you can check it. First, you can check it, no matter. Yeah? We're done. For sure. Okay, now, these ones. All right. It says solve the equation now with complex numbers, meaning that your expect the I to appear if you get them. Okay, make sure you use each method, factoring, complete and square. Oh, at least once. Let me ask you, do you have to do that? You have to follow that to the T. The factoring is like what we did, like guess and check. The complete and square is longer. Quadratic formula is longer. So you can do all three, like the first, second, and third. What do you think? Do you think we should do exactly that? Or you can do any way you want? What do you think?
You just do whichever one. We'll usually try the factoring first, and then if it doesn't work, then see which one you
Yes,
want to do.
yes, exactly. That's actually should be the actual practice for sure. No matter where you if if and only if they don't tell you this this right here, get it? They say soft. Is it soft? Then you can do that for sure. But what do you think? They do have a you know, what do you call it, condition to this? What do you think? Will your teacher be
I think they're
okay?
just saying like at least once in these whole amount of numbers. So I think eventually we'll have to use them. So I think we'll be fine.
Yeah, make sure to use each method at least once. Do you see what I mean? Yeah, each method, meaning that you have to use these three once at least. I know you might be interpreting it wrong, but I'm seeing that you have to do it. What do you
Yeah,
think?
but it says from 34 all the way to 45. So
Oh, oh,
eventually
oh, you're
we'll
right.
use it.
You're right. Oh, good catch. Yeah, I'm lame. I'm tired. You're right. You're right. Oh, right. Okay. So, all right. Okay. Good point. So let's do the ones that you can do the factoring easily. Is that okay? So we'll do the quadratic and the complete square for the ones that like minimally, like maybe one. Try not to do it at all. But however, but there's a big but here. You may have no other choice other than quadratic formula. If you have a choice between these two, you do quadratic formula. But we're only going to do complete square once. But quadratic
Okay.
formula, you have to do it when you cannot do it by factoring. You get it? You have no other choice. Yeah, or complete the square. But these two, you're flexible. You can do whatever. But then we have to do all, at least once. So and then continue on. I'll always going to go quadratic if you cannot do it by factoring. So okay, let's do it right now. So this one, you can factor 5 out. Factor out 5, x squared minus 25. Yeah, 25 times 5 is 125 equal to 0. So you have to set each factor equal to 0. This one, you cannot set equal to 0, so you ignore it. So you only set this factor to solve. So set that equal to 0 and then solve. Now there's two ways of doing it. You either do a plus or minus, but let me go ahead and add both sides by 25. I think this is kind of okay. I hope you're okay with this. Add both sides by 25 and then square root it, but you got to do a plus or minus. Is that okay? Like that.
Yeah.
Then your final answer, the two answers will be plus or minus, both of them. You could leave it in a plus or minus form. 5. Done. Another way of doing it is like you factor it as an x plus 5 and x minus 5, and you set each one equal to 0. Do you remember that one? Right there? Yeah, you can do that. It'll give you the same answer. Equal to 0 here. And the 5 you can ignore again. The 5 in the front. Okay, this one. I will just be aware though, if you don't have a 0 on the other side, bring it over. Especially when you have like the two variables there, like A, B, C form, you have to bring the 14 over and get a 0. You need a 0 on this side. But had it just been without the B here, you don't need it. You can leave the 14 over there, just like the one we did here, like right there. But then you have two variables, like the square and the first power line. You need this to be 0. If you didn't pick that up, you have to do it. So let's bring it over. So I'll subtract 14 over equal to 0. Now, before you complete the square or do a quadratic formula, try to factor it first. So let's see, 3b, b, 14. I'll do a 7 here and a 2 here. I hope I get a 1 back here. And I will. So I'll keep it. Here's a 6b and a 7b. I can subtract to get a 1b. Is that okay? You see that? So therefore, I'll keep the 7 and 2, but what about the sign? Well, the bigger one got to be here because I want a positive b. So a 7b got to be the bigger one, and then minus here. Yep. So 7b minus 6b. Yep, done. But then that's just for factoring. Then you have to set each factor equal to 0 because of this. So show that. Or you can write the answer. Let me see. I'll write the answer right away. Pretend I set each factor equal to 0. So therefore, b is going to be equal to negative 7 halves. Can you see it that fast? Subtract both sides by 7, divide both sides by 2, by 3. 3. 7 thirds. See that? Okay. Do you want me to write it?
No,
Okay,
I
let me.
see. It's good.
Okay, yeah. Imagine you set this equal to 0. Subtract both sides by 7, -7. Did I write that the first time? Divide both sides by 3, -7/3. Then this one's add both sides by 2. Therefore, b is equals to 2. Done. Okay. Okay, this one you were doing the 4-term factoring before. You have to do it here. But before, can you look at you want to look at the number kind? Can there be a number that pull out other than 1? No. Therefore, you go at it. So you're gonna, yeah, no GCF here. So cover the first two. Cover the last two and factor the first two. X squared can be factored out. X squared times 2x plus 5 will give you back all that. Okay, x squared, yeah, x squared third, 2x third, and then 5x squared, yeah. And then again, do the last two. That's a plus, then this is a plus. So the common factor for the 200 and 500 will be 100. Yeah, careful. If you do 10, then you realize that you got to pull out another 10. So it'll be 100 times 2x will give you 200x plus 5 equal to 0. Now, see, if you do it right, you match the two bubbles here, the one in the parentheses. Okay, now I'm going to pull this out in the front one time or in the back. But this time I'll pull it in the front again. And then this individual back here plus 100 equal to 0. You probably like seeing this because now it's like you're remembering it, right? The pattern. Yeah. And then set each one equal to 0. So this one, I think you're okay. X equals, subtract both sides by 5, divide both sides by 2. So it's -5/2. This one, let me write it because you have to be careful here. Equal to 0. Set each factor equal to 0 and solve. This one, subtract both sides by 100. So you're left with x squared equals -100. And then you square root it. But you do a plus or minus on the other side, but still you have a -100 inside the root. And here it is, your imaginary answer. So the answer should be, remember, you have a negative inside, just the I, pull out the I. So I'll write it. I'll show you the work here. It's the same thing as a -1 times -100 here, but it's still plus or minus, okay? So it still be plus or minus, but then this is I. So you write I times root of 100 is 10. That's why that's the answer. But then switch it around, make it like normal. It'll be 10i, plus or minus 10i. There it is. Circle all three. Okay, they're all three answers here. Sorry, because you have a third power equation. That's why you have three answers. But it happens that two are complex or imaginary. Okay, continue. This one. All right. Factor. Do it by hand first. Yeah, we'll do eventually complete the square and quadratic formula. I think it's going to happen automatically for quadratic formula. So here, but let's do this right now. I'll do 3 and 1. I'll do 3 here and 1 here. Well, it's not going to work because 6 and 1, I can never add or subtract to get a 3 out of it. So let me switch first. I'll switch. I'll switch it. I'll have 3 here and a 1 here. The outer is 2, the inner is 3. 2 and 3 will never give you. Here it is. This is going to be your first quadratic or completing the square. So, okay, I'll say this. So this one is not factorable by hand. Let me double check. Yeah, it's not factorable by hand. But then you may be asking, do you want to complete the square or do you want to, so you don't have to erase it, just kind of scratch it so your teacher knows. Here, you will never want to do a complete the square with the number other than 1 in front of the x square. So this is a huge thing. You could, but it's very messy, long. So therefore, you don't want to pick this one to complete the square. You can do it. I can do it. I can show it to you. But you don't want to do it because it's long. It's messy too. But you can do it. They have shown, they have taught you this. I'm sure your teacher have shown you this, but don't do it. This one is going. This is the one that you're going to complete the square because of this being a one. If we need to, okay, yeah. So anytime you want to complete the square, look for the leading coefficient of the trinomial to be a one. This one can be done, not this one. Yeah, you don't want to complete the square here because you need the ABC form. Or I mean, completing the square. You need ABC. You need a B. You need a B. A variable in front of like the B part is right here. The thing that the first power. The -4 is B. But okay, let's do a quadratic formula here. Okay, so here we go. Quadratic formula. This will be your A. You need your A to be yeah, your A could be anything for quadratic here. So C. Here we go. Let's do a negative. Do you have the formula memorized? So it's going to be a negative B, which is -3 plus or minus B squared. Do you want me to write the formula for you? You have cheat sheet, right? You can write cheat sheet, right? So
Yeah.
I'll write it. I'll write it for you. You can copy this for cheat sheet here. So it's going to be negative B plus or minus square root of B squared minus 4 times A times C inside the root all over 2A. So this is the formula we're going to use, plus or minus here. Okay, so here we go. Let's do it. X equals negative B will be -3. You can parenthesize that to show that you plug in. And 3 squared, it'll be 9. I'll skip the show plug in. 4, I will show the 4 substitute A and B here. 4 times A, which is 2, times B, which is 3. All over 2 times A, 2 times 2. 2 times 2. Okay, clean this up. So you're left with -3 plus or minus inside the root. Let's see. In 9 minus, what is that? 8 times 3, 24. Is that right? Double check. Yeah. Or 4 times 3 is 12 times 2. Yeah, it's 24. And then you get a negative, what is that? 15. Yeah, -15. Is that okay? Inside the root. Then the denominator is 4. Okay, continue here. So we're pretty much done. I'm glad we picked this one as the quadratic formula. So this here, just pull out an I. So it'll be an I root 15. Now, what about 15? Yeah, you cannot rationalize that because it's 3 times 5 inside the root. There's nothing you can pull out. So you leave it as 15. So that's why this is a nice one. Just like that. And this is your final answer for a quadratic. You okay? Yeah. All right, that's done. Let's try to factor this one by hand. So n, looks weird with my parentheses here. Be more neat here. N, 2, 2. Yeah, number close to each other. Can I get a -4n? Yes, if I do it like this. And then I can check -2 times -2. Yeah, I get my +4. So this is it. But then if you're solving, I recommend you write it as like the squared form, like this. And then you want to do a square root principle, or law of square rooting or whatever. Oh, let me think. Yeah, you don't have to do anything. You don't have to do that. I'm sorry, dude. You would do that if this is a number here. But remember, we got a 0. So anyway, the answer is just 2. Get it? Yeah, n equals 2. Yeah, so n equals 2 is the answer. It doesn't matter which one you set equal to 0 to. So n equals 2. Done. This one, factor out the x squared and the 2. Yeah, 2 can divide into, because the leading coefficients are even, but the GCF is 2. 2 can be the one that can divide into, the biggest one that can divide into all the coefficient. But then at the same time, the x squared can be pulled out. So the GCF is 2x squared. But this time we're going to need to use it to set it equal to 0. But then let's continue. 2x squared times what will give you 2x to the fourth, which is just going to be 2. It's just going to be x squared. 2x squared times what will give you 12x to the third will be 6x. Yeah. And then 2x squared times what will give you a -40x squared. 20. right? Yeah, that's it. That's it right there. And then set, well, don't set each one equal to 0 just yet because this one can be factored, has to be factored. If not, we'll use quadratic formula or completing the square. But then, yeah, it'll be pretty messy here. But let's try it by factoring first by hand. X, 5 and 4, the number close to each other first. Nope, I will never get a 6 back. Like outer, inner, I'll never get a 6. At most it's 9, at least it's 1. So I have to do another combination. A 10 and a 2? No. Okay. What else? 20 and 1? No. Yeah, that means you have no choice other than completing a square. Let's complete the square here. Yeah, it's not factorable. So you don't erase it, just scratch it. But leave this alone. This is going to be part of the factor you need to continue with. So, okay, let's do the completing the square. Oh, man. It's not nice when you have something in the front here. But okay, so take the b divided by 2. We're completing the square just right here. And square it. You get a 3. I'll write all the step. I recommend you write it this way because that 3 in the parentheses, it's going to be the number you need to use. Be a 9. Okay, a 9. Here's the thing though. Try to do it like this. Just do it with me this way because since we have this in front, it will be very bad if you're going to do it to both sides. You know, I think you remember doing something adding to both sides after you complete the square. Don't do it. Let me show you the easy way. And you probably like doing this. So watch, here we go. Keep this outside, but inside the parenthesis, that 9 that you got, all you do is like this. Plus, you always have to plus it. 9. Now, you're probably wondering, hey, Toss, I remember you something about adding this 20 over on the other side and all that, right? No, don't do it. Don't worry. This is even nicer. Just leave it there. But when you do the completing the square process, this is it, like the scratch work. The number that you got by completing the 9, you just add it back into the right behind where the trinomial here. Just add it back here behind the 20, but then subtract 9 also. Okay, don't worry. You wonder. You could have always done this, by the way, but you guys been adding it to the other side. It's all messy, but don't do it. But watch, it's easy. But then you ask me, how do you know to do this? In pre-cal, you do this. So, dude, yeah, you don't add it. But some teachers still make you do it. But in pre-cal textbook, they say, don't do that. Go ahead and just put it where you left off, right behind the trinomial that you're attempting to complete the square. Add and subtract. Simple. And it's always true. If you actually combine this, you get this back, the original back, right? If you want to, but you don't want to do that because you got the 9 for a reason. But let's continue. All right, so just do that. Yeah, complete the square in here. Now, how do you continue? Nice, watch. What you do is this. 6x. This, when you combine, you only combine the plus 1. The minus 9, leave it back there. So it'll be, what is that? It's a minus 11. Yeah, this 2 here. And then minus 9. You won't wait. Should you not combine the 9? No, don't combine it. There's a reason for you not to do that. Okay, equal to 0. Now this is maybe a little awkward, but it's still it's very sensible. It'll make sense to you. Watch. I'm gonna now factor this. Let me double check if I did that right. Negative 20 plus 9. Is it negative 11? Right? Yeah. Okay. Oh, I made a mistake somewhere here. I think I did. It has to be, this has to be factorable after you do it. If you do it correctly, it'll be factorable. It's right here. That's what that is. Okay, I see. No worry. Okay, wait. Okay, back. Erase this part here. Mine, I have to back it all the way. So yeah, I forgot. Okay, from here, right? The 20, you got the 9. So this is what you did. You get the 9. So what you want to do is that instead of actually write it behind the 20, the minus 20, you write it behind or in front of it, The plus, is that okay? But then put the 20 back and then minus 9 in the back. Don't forget that plus and minus is important. You need to do a plus and a minus 9. But you choose the plus right in front of the 20 or behind the x term. Like that. Let me bubble that, I guess. Yeah, write the 9 and the minus 9. But the minus 9 could still be behind this one. Look, let me show it to you. It doesn't matter. You could still write a minus 9, but the 20 still had to exist. But the plus must go first, right behind here. Doesn't matter. Let me do a minus 9. So you know that it's still true. And then minus 20. Yeah, you can put it anywhere, but you need the plus first for the trinomial. So I'll do that at 20 here, okay? Equal to 0. Okay, I hope you're okay. You can put it anywhere. You can switch this around if you want, but you need this plus 9 to be right immediately behind the x term. That's it. Try to remember that when you need to do it again. Okay, now you can factor the trinomial perfectly. The trinomial can now be factored, but the back number here can now be combined, which is going to be negative 29. This here, if you factor the first 3, it's perfect. It's this number, dude. That's a plus. It's a plus. It's the plus 3 every single time. There you go. There you go. Now we're almost done. Look how nice this. If you do it this way, this is pre-cal. If you do this way, it's clean. But just have to remember to organize this nice. The thing that the perfect square number that you got immediately behind the x term of the trinomial, right? And then everything else indented over. You don't have to worry about how you organize the minuses back here. Well, don't forget this doesn't have to be a minus. It could be whatever. But whatever that is, a plus 20, it'll be a plus 20 here. Is that okay? But it's a minus 20, so you have to keep it minus 20. But anyway, if you continue, it's such a nice factor looking. Watch. Here's what happens if you do continue. Now, I know I bracket them just to be neat, but then I'll take out the bracket, and then now it would look this way. Watch. Oh, I'll have to keep the bracket. Sorry. Yeah, I have to keep the bracket. Yeah, keep the bracket also. So if I combine them, it will look like this. Rewriting it squared minus 29, close bracket, equals 0. Why is this good? Now you can continue setting each factor equal to 0. This one and this whole one. So watch. I need space, but I'll squeeze. Okay, I'll squeeze it here for this term. So 2x equals 0 equals 0. So x equals 0. I hope you're okay. That's one answer. Then this whole one here, you have to bring it over. You have to set the whole thing equal to 0. So here we go. Everything. Minus 29 equals 0. Okay, right there. And then solve. Add both sides by 29. Okay, and then square root principle or law of square rooting, whatever they call it. In different books, they call it differently. Square root principle seems to be most common. Square root the other side plus or minus it, and then you just drop that. I think you might recognize that. And then you're almost done. I mean, I think you guys do it like this: square root both sides, but you have to do it plus or minus here. Okay. Okay, continue. And then subtract both sides by 3. Put it in the front of the plus or minus, and then you're done. That's it. The 29 is a prime number, so you don't simplify that or rationalize that. So you're done. So you got 3 answers here: the 0 and this 2 here, and it's fourth power. Let me see. Oh, it's okay. Here's why: because you remember the x squared. You get 0, but it basically count for 2, right? You see that? Yeah. The 0 answer counts for 2. Or if you recall, it's the bounce. Remember the bounce in the graph? So don't worry. Anyway, those are the answers. It bounced, therefore it doesn't go through it twice. So it bounce, it count as 1. Like the graph bounce on the x-axis, and this here it'd be like 1, 2 right there. So that's why this count as 2, and then 3, 4 all together. Fourth power equation. So normally you get 4, but this one you get 3. No problem. So done. All right, almost done here. So we did what we need. Now we can always try to factor by hand. Did you copy that? Okay.
Yeah.
Okay, continue here. Y, 6 and 1. Perfect. Subtract, because I can get my negative 7y. See that? Outer negative 6y, inner negative 6y, negative 7y. And also I get a plus 6 back if I multiply the last, negative 1 times negative 6. And the first is y squared. Then set each one equals 0, y equals 1, y equals 6. Done. This one is easy. Just go ahead and square root both sides, but do plus or minus on the other side. 144. Okay? And then you get w equals plus or minus 12. Done. Yep, there you go. 41. Okay, last one here. All right, factor 5c. And okay, I'll tell you. You can do 3 and 2, but this time, from my experience, it'll be 6 and 1. Yeah, don't worry. Just try what you, because why is it 6 and 1? Because outer is 12, inner is 1. Oh, got my C here. I'll get my 13. You see that? Yeah, if you do enough, you'll be able to do an educated guess. If you do a lot of this, you'll know it. So this works, done. So it's plus and plus. And then you set each one equal to 0. Subtract both sides by 1, divide both sides by 5. Therefore, it's negative 1/5. Subtract both sides by 6, C equals negative 6. Done.